Hello everyone, in this video we will see some important concepts in graph theory. Before we begin the session, don't forget to subscribe to our channel. What's in it for you are, first we will see what is walk, in that we will see the types of walk. And next we will move to the trial and then circuit. And after that we will see what is cycle. And once this is done, we will see what is path. And finally we'll end the session by looking after some examples. In graph theory, walk is defined as a sequence of edges and vertices in a network. And we can say it is the way how we move around a graph. If we start at a vertex and then we move along an edge to a new vertex, then we are starting a walk. If we have a directed graph, we move in the direction of arrows. We can continue the walk by selecting another edge coming out of the second vertex, then third edge coming out of the third vertex, and so on. It can start and end at any vertex and can repeat the vertices and edges. The total number of edges covered in a walk is called length of the walk. In graph, there can be more than one walk. So for a walk, the 2 points are important. That is, edges can be repeated and vertex can be repeated. In a simple graph, we can represent a walk by sequence of vertices. Here is a simple undirected graph with arrows representing a walk around the graph. We can record this walk as a sequence AB, AE, FDE. In this example, we have a graph. In the graph, there can be many walks. Some of them are given here. First sequence can be AB, CE, D. And here the number of length is 4. And the second sequence can be D, B, A, C, E, D, and C. Here the length of the walk is 7. And one more sequence, in that we have E, C, B, A, C, E, D. And here the number of length is 6. Next, the types of walks. There are two types of walks, open walk and closed walk. A walk is said to be an open walk if starting and ending vertices are different. That is, the origin vertex and terminal vertex are different. And the length of the walk must be more than 0. A walk is said to be a closed walk if the starting and ending vertices are identical. That is, if a walk starts and ends at same vertex, then it is said to be closed walk. And there are some important points to be learned. That is, the walk is said to be trivial walk if the length of the walk is 0. Next, in case of open walk and closed walk, the edges and vertices can be repeated. Here is an example for closed and open walk. The closed walk sequence is A, B, C, D, E, C, A. And open walk sequences A, B, C, D, E, C. And as I mentioned earlier, the closed walk will start and end at the same vertex. And next we have trial. Trial is a walk where no edges are repeated. That is, trial is a walk with no repeated edges. We can also say that if a walk does not use the same edge more than once, then it is a trial. It is an open trial if it is open, and a closed trial if it is closed. The closed trial is also called as a circuit. Here is an example for open trial and closed trial. The blue walk A, D, F, E, D, G, C, F on the left is open trial, since no edge is used more than once and it is open. The red walk G, C, F, E, D, F, A, D, G on the right is closed trial, since no edge is used more than once and it is closed. So for trial, the important point is the vertex can be repeated. Here is an example for trial. The open trial sequence is A, C, H, F, C, B. And the closed trial sequence is A, C, H, F, C, B, and A. For closed trial, it starts and ends at the same vertex. Circuit. Circuit is a path that begins and ends on the same vertex. And we know that trial is an open walk with no edges repeated, whereas circuit is a closed trial with no repeated edges but may have repeated vertices. So for circuit, the two important points to be remembered are edges cannot be repeated but vertex can be repeated. Here is an example for circuit, and the sequence is A, B, D, C, F, H, C, A. And here the circuit is closed trial as it has the repeated vertices. Let's see some important points about the trials and circuit. A trial is a walk where no edge is repeated. An open trial starts and ends on different vertices. A closed trial is also called a circuit, which starts and ends on the same vertex. All the trials are walks and all the circuits are closed walks. And next we have cycle. A cycle is a trial that finishes on the same vertex it begins on. A closed path in a graph theory is called as a cycle. That is, when a path begins and ends at the same vertex, it is a closed path, which is usually called a cycle. So for cycle, the 2 points to be remembered are edges cannot be repeated, vertex also cannot be repeated. In this figure, the open path on the left is D, G, C, F, E, A. And the closed path, which is also called a cycle on the right, is B, C, F, D, E, A, B. Here is an example for cycle. Here the cycle is closed path and the sequence is A, B, D, C, A. And next we have path. Path is a trail that connects all the vertices. It can also be defined as an open trail with no repeated vertices. If a walk does not use the same vertex more than once other than start and end vertex, then we call it as a path. And in this figure, the open path sequence is D, G, C, F, E, A. In an open walk, the length of the walk must be more than 0. For path, the two important points to be remembered are edges cannot be repeated, also a vertex cannot be repeated. Here is an example for path. The sequence is F, H, C, A, B and D. To sum it up, path and cycle. A path is a walk where no vertex is repeated or no edges cannot be repeated. An open path starts and ends on different vertices. The closed path is also called a cycle, which starts and ends on the same vertex. So all the paths are walks and trails. And all the cycles are closed walks and closed trails. So the above definitions can be easily remembered with the help of the chart. And we know that walk is any route along the edges of a network. And trail is a walk with no repeated edges. And path is a trail with no repeated vertices. And a circuit is a closed trail. And a cycle is a closed path. Let's see some examples. First we will consider a graph. Now we have to find out which sequence of vertices determines the walk. The sequences are given here. For the sequences of walk, we have to determine whether it is a cycle, path, circuit or trail. And in the given graph, A, B, C, D, E, F, G are vertices. And the line between two vertices is edge. That is, the line between A and B is an edge. To solve this, we first determine the sequence number 1. After that, we will proceed to the next. Sequence 1 is a trail because there is no repeated edge in the sequence A, B, G, F, C, D. The sequence 2 is a walk because the sequence B, G, F, C, B, G, A contains repeated edges and vertices. And sequence 3 is a cycle because the sequence C, E, F, C does not contain any repeated vertex or edge except the starting vertex C. And next, the sequence 4 is a walk because the sequence C, E, F, C, E contains the repeated edges and vertices. Next, sequence 5 is not a walk because there is no directed path to go from B to F. That's why we can say the sequence A, B, F, A is not a walk. And next, the sequence 6, it is a path because the sequence F, D, E, C, B does not contain any repeated edges and vertices. Let's see another example. So with the help of below sequences, we have to determine the nature of walk in each case. In the graph, V1, V2, V3, V4, V5 and V6 are the vertices. And E1, E2, E3, E4, E5, E6, E7 are the edges. First, the sequence number 1 is an open walk because the starting vertex and the last vertex are not same. The starting vertex is V1 and the last vertex is V2. The sequence number 2 does not have a path. It is a trail because the trail can contain the repeated edges and vertices. And the sequence V4, V1, V2, V3, V4, V5 contains the repeated vertex V4. Next, the sequence number 3 is a path because the sequence V1, E1 and V2, E2 and V3, E3 and V4, E4 and V5 does not contain any repeated edges and vertices. And next, the sequence number 4 is a cycle because the sequence V1, E1, V2, E2, V3, E3, V4, E7 and V1 does not contain any repeated vertex or edge except the starting vertex V1. And sequence number 5 does not have a cycle. It is a circuit because a circuit can contain repeated vertex but it cannot contain repeated edges except the starting vertex. The sequence V6, E5, V5, E4, V4, E3, V3, E2, V2, E1, V1, E7, V4, E6, V6 contain the repeated vertex V4. Let's see one more example. And the sequence related to the graph is given here. And we have to determine the various answers to the following questions. In the given sequences, we have to determine which sequence is directed walk. Next, we have to determine the length of the directed walks. Next, we have to determine the directed walks which are also directed paths. And finally, we have to determine the directed walks which are also directed cycle. So for the first question, here the sequence number 1 and 2 are directed walks. because the directed walk can contain repeated vertices and edges. The sequence 3 is not a directed walk because the sequence D, A, B, E, D does not contain any edge between A and B. And sequence 4 is also not a directed walk because the sequence D, B, E, C, B, A, D does not contain any edge between B and A. And next we have to determine the length of the directed walks. And we know that the sequence number 1 and 2 are directed graph. So we can find the length of the sequence 1 and 2. So the length of the directed walks 1 and 2 are 4. And next we have to determine the directed walks which are also directed paths. The sequence number 3 and 4 are not directed walk. So we will find only whether the sequence 1 and 2 are directed path. The sequence 1 and 2 are not directed paths because both the sequences contain the repeated vertex. That is, the sequence number 1 contains the repeated vertex B and sequence number 2 contains the repeated vertex A. And finally we have to determine the directed walk which are also directed cycle. Here the sequence number 1 and 2 do not contain the directed cycle because the cycle does not contain any repeated vertex or edges. Here the sequence number 1 contains the repeated vertex B and sequence number 2 contains the repeated vertex A. And there are some important points which should be learned when we study discrete mathematics. Every path can be a trial, but it is not possible that every trial is a path. In discrete mathematics, every cycle can be a circuit, but it is not important that every circuit is a cycle. And if there is a directed graph, we have to add the term directed in front of all definitions. In both the walks and paths, all sort of graphical theoretical concepts are considered. For example, if we have a graph and we want to determine the distance between two vertices, in that case we will consider the shortest path which begins at one and ends at another. And here the length of the path will be equal to the number of edges in the graph. And that's all for this session. Thank you so much for watching.